Hey guys, we're going to look at section 6.2, which is on the graph of exponential functions. This is going to be a really quick section, and I'm not going to assign any homework from it. It's important for you to know what the graphs look like, but the homework is not, the homework problems in the book I don't think are very instructive. So let's just look at this a little bit. Exponential functions. Exponential functions have this sort of form. You just got b to the x, and b is a positive number other than 1. Now, the graph of this looks like this. Actually, I'm going to move this. Axis over a bit. Say to here. Let's graph y equals 2 to the x. Just to pick a value of 2 for my b. It's going to look kind of like this. Actually, let's plot a few points. If I'd been thinking ahead, I would have put some tick marks on this page, but that's okay. When I start graphing this, right here, 2 to the 0 power is 1. So let's see, let's graph this in purple. 2 to the 0 is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third is 8, so that's going to be up here somewhere. And when we go backward, we're going to have 2 to the negative 1 power is a half. 2 to the negative 2 power is a fourth. Then an eighth, and then a 16th, and a 32nd, and so on. So when you connect this together, you've got this horizontal asymptote going back. And over here, it grows to infinity very quickly. I'm going to make that dot bigger so that it touches. But all exponential curves have this sort of graph. Notice the domain is going to be all reals. The range, notice it goes up to infinity, but it never goes below 0, and it never actually hits 0. So the range is going to be everything from 0 to infinity, not including 0. Horizontal asymptote is going to be the y-axis. The x-axis. And it's always going to pass through this point 0, 1. And that's true for any base that we pick. On this one in particular, I picked 2, but this is going to be true for any base that we pick. Now, if I start varying this, and let's use Desmos so that we can look at a nice drawing. If we look at this and we say y equals 2 to the x, notice we get this graph. Let me move it down a little bit so we can see it a little better. So that's 2 to the x. If I put in y equals 3 to the x, notice it has the same general shape, but it grows faster. If I change this to 4 or 5 or whatever, the bigger the number, the faster it grows. But notice they all go through this point here, 0, 1. Now, earlier I said that the graph had to, or that the base had to be a positive number other than 1. If we put something in that's less than 1, what's going to happen is it's going to reverse it. If I put y equals 1/2 to the x, we get an exponential decay curve like this. And you can see this if you wanted to by saying this is, 1/2, that's 2 to the negative 1. And I could rewrite that if I wanted to as y equals 2 to the negative x. So putting in, 1/2 to the x, it's the same as reversing the graph, flipping it horizontally. All right, let's look at something else. Let's see, if I put in 1/2, that's not something else. If I put in 1/2 to the x, we get this. If I put in 1/10, make all of that to the x, This is also going to be a decay curve, and it's going to decay a lot faster. So that red graph there really hugs the axis really quickly. What's the one number we can't put in? I said we couldn't put in 0. Or no, I said we couldn't put in 1. Why is that? Well, if you put in y equals 1 to the x, I mean, it's a valid function, but it's not exponential because it's just a line. So that's pretty much it. There's only one other thing I want to do. I said it has to be a positive number. What happens if you put in a negative number and raise it to the x? Well, let's see. Put in negative 2 to the x. What we get is not going to be an exponential function. This is not even graphing it for us. So 2 to the x, it won't even graph it for us. The thing is, you run into some problems there because, you know, negative 2 to the x, we could graph that for some numbers. Like negative 2 to the 0 would be 1. Negative 2 to the first power would be negative 2. Negative 2 to the second power. We could do all those integers, but we'd run into problems at places like at x equals a half. We'd get an imaginary number, and the same thing would happen at a fourth and an eighth, and at any fraction that has an even denominator. So we can't get an exponential function if we use a negative base. All right, that is all I want to say about exponential functions.